Good morning everyone. As we all know that we are facing COVID-19. So there are certain guidelines for the COVID-19. The first one is wear mask properly, wash your hand regularly with the help of soap and water. And the main important thing is keep the social distancing, maintain the social distancing, maintain the physical distancing, and do not share the water bottle and eatable with any other person. Now come to the topic, that is the second law of thermodynamics. We have already studied the first law of thermodynamics. So in the first law of thermodynamics we have a derivation. We also have the derivational form of first law of thermodynamics, but in the second law of thermodynamics we have only the statement in our syllabus. So the second law of thermodynamics can be stated as whenever a spontaneous process takes place. Now here the word used spontaneous process. So the meaning of the spontaneous process means the process which occur on its own. The process which occurs on its own is known as spontaneous process. So whenever a spontaneous process takes place, it is always accompanied by an increase in the total entropy of the universe. So when the spontaneous process takes place, so definitely there will be the increase in the entropy. Now the entropy, increase in the entropy, and in the above statement the term universe means the system and the surrounding, because earlier we have studied that the meaning of the universe is equal to it is a sum of system and surrounding. Therefore delta S, that is the change in entropy of universe, is equal to delta S system plus delta S universe. So this is the observation for the second law of thermodynamics. So this is the definition. This we can say that it is stated as, or it is a definition for the second law of thermodynamics. Now there is a new term that is, this is the next heading, that is Gibbs energy. Gibbs energy and spontaneity. Gibbs energy and spontaneity. Gibbs energy and spontaneity. So the maximum amount of energy available to a system during a process that can be. Now the next topic is Gibbs energy and spontaneity. So the maximum amount of energy available to a system during a process that can be converted into useful work, called the free energy. That is called the free energy, or Gibbs free energy. Free energy, or we can say that the Gibbs, that is Gibbs free energy, or sometimes we also call it as a Gibbs energy. So the free energy, Gibbs free energy, or the Gibbs energy are the same term. So it is called the Gibbs free energy in the early literature, but in accordance to the IUPAC recommendation, we shall use the term free energy. So now we are using this term, that is free energy, for the Gibbs free energy. Earlier we have used the term Gibbs free energy, but now we use the term free energy. So the free energy is denoted by capital G. It is denoted by capital G, and mathematically it is expressed as, that is G means free energy, is equal to H minus Ts. G is equals to H minus Ts. Now what is H? H is for the enthalpy. So H is the enthalpy of the system. This is the enthalpy. This one is the enthalpy of the system. S is the entropy. S is the entropy and T is the temperature. So H is the enthalpy, T is the temperature and S is the entropy, and this T is the absolute temperature. This T is the absolute temperature, and the term G is used for the free energy. This G designate the free energy. So the Gibbs function, that is G, it is an extensive property. This one is the extensive. This one is extensive property and a state function. This one is the extensive property and a state function. So the change in the Gibbs energy for a system, if there is a change in the Gibbs energy for a system, so for that we can write it as a delta G SYS. So delta G is the change in the free energy or the Gibbs free energy, and SYS represent the system. So it can be represented as, that is, delta H system minus T delta S system minus S system delta T. So this is the expression. This one is the expression to represent the Gibbs function or the Gibbs energy. So at constant temperature, it means delta T is equal to 0. Constant temperature means delta T is equal to 0. So delta G system is equal to delta H system. Delta G system is equal to delta S system minus T delta S system, because this value is 0, because delta T is equal to, we have a sign here, delta T is equal to 0. So delta T multiply S system is equal to, the whole term will be 0. This whole term will be 0. So delta G system is equal to delta H system minus T delta S. So we have such expression. So usually the subscript, this is the subscript, this is the system, these words are the subscript. So usually the subscript SYS means it stands for the system is dropped, and equation we can write it as a delta G is equal to delta H minus T delta S. Now we eliminate, we remove all the subscript, that is the system, and delta G is equal to delta H minus T delta S. So the above equation, this equation, delta G is equal to delta H, that is the change in the enthalpy, minus T is stand for the absolute temperature, and delta S stand for the change in the entropy. So this is the Gibbs, this expression is called Gibbs Helmholtz equation. This expression is called Gibbs Helmholtz equation, or simply Gibbs equation. Simply Gibbs equation. This equation is called the Gibbs Helmholtz equation, or simply Gibbs equation. Now here delta G, this is change in free energy. Delta G is equal to change in free energy. This delta H, this is change in enthalpy. This is called the change in enthalpy. T stand for the, this one is the absolute temperature, and this delta S, this is called change in entropy. So this whole expression is for the Gibbs free energy or the free energy. This is for the Gibbs free energy or the Gibbs energy. So by the help of this equation, we can find out the value of delta G, or sometime delta H, or T delta S. So we can easily find out the any kind of a value with the help of the following expression. Now the next topic is that is relation between that is G, delta G, that is gives free energy, and EMF of the or of a cell. So this is our next topic, that what is the relations between the gives free energy and the EMF of a cell. So the free energy change means delta G. Free energy change is related to the electrical work. Free energy change is related to the electrical work done in the cell, and it is represented as delta G is equal to minus NFE cell, minus NFE cell. So now here we have a various term. The first term is E cell. So the meaning of the E cell is this is the EMF of the cell. E cell means EMF of the cell. EMF means electromotive force. EMF stand for the electromotive force. Now the next one is the N, this N. So this N is the number of moles of electrons involved. This is the number of moles of electron, number of moles of electrons involved. Number of moles of electron involved. Now here F. This F is the Faraday constant. This is Faraday's, this one is the Faraday's constant. F is the Faraday's constant, and the value of the F is 96500 coulomb. 96500 coulomb. So this is the value of Faraday's constant. And now if the reaction and the product are in their standard state, if the all the reactants and all the products are in their standard state, so at that time we use the term naught. That is delta G naught is equal to minus F E naught cell. So this sign represent that all the reactants and all the products are in their standard state, and that time E naught cell, we call E cell is equal to EMF of the cell. But when it is present in the standard state, that is E naught cell, when it is present as a E naught cell, then that time it is termed as the standard cell potential. E naught cell stand for the standard cell potential, and E cell stand for the EMF of the cell. So now the last topic of this lesson is, that is third law of thermodynamics. That is a third law of thermodynamics. So this law was proposed by a German chemist, Walther Nernst. That is Walther Nernst. So the third law was proposed by Walther Nernst. And according to the third law of thermodynamics, the entropy, now we know what is the entropy, we know the meaning of the entropy. According to this law, the entropy of a perfectly crystalline substance, the entropy of a perfectly crystalline substance approaches zero. The entropy is approaches to zero as the absolute zero of temperature is approached. as the absolute zero of temperature is approached. So it formed the basis from which entropy at other temperature can be measured. So that is the limit. T approaches to the zero, so entropy is zero. Now the S is the meaning of S. S stands for the entropy. For example, in case of the carbon monoxide or nitrogen oxide molecule in the solid state, there is a randomness even at 0 Kelvin due to their dipole moment. Hence, the entropy in such cases is not zero even at the 0 Kelvin. Even at the 0 Kelvin. So this is the third law of thermodynamics, which was proposed by the Walter Nernst.